Hello and welcome back one and all. In the previous session, we created a Redshift cluster and established connection to this cluster via DBeaver from our local PC and from Redshift query editor. We have created a table in the Redshift database. In this session, we will build on it. We will connect to this cluster from AWS Glue. We will create a crawler to infer schema and import data into Redshift table from S3. So this is the table we have created in the last session. Let's go ahead and open up AWS Glue and we will add connection to the Redshift cluster. We will click on connection and give this connection a name. I'll call it RDS and select Amazon Redshift from the dropdown. Click next to continue. We will select the cluster from the dropdown and the database and the user information is auto-populated. We will supply the password for the database. Let's click finish to save this connection. Let's go ahead and test it now. We will select the connection and click the test button. In order to access the cluster, we need to select the IAM role and click on test. This will try to establish connection to the Redshift database. It can take a little time as this is going to utilize the endpoint, the routing table, and the security group in the VPC to reach to the database. Okay, the connection to Redshift is successful, and it wasn't as long as I expected. Now we can define a crawler. So we'll go ahead and click on crawler. This crawler will crawl the Redshift database. Let's give it an appropriate name, and rest of the setting we can leave as default. Since we are going to crawl a data store, we can leave it as default. And on the next page, we will select the JDBC data store. And here we will select the connection we defined earlier, RDS. Under the path, we need to supply the database / schema and the table name. So the database is dev and the schema is public. Instead of defining a single table, we can use the % symbol to crawl all available tables in the database. So we'll go ahead and use the % symbol. On this screen, we also have the option to exclude certain tables. Okay, so this is the only data store, so we can go ahead and click next. I will select the first IAM role and click next. For the schedule option, we will leave it on demand. And to store the table's metadata, we will select the AdventureWorks database. So once the crawler is done inferring the Redshift schema, the table's metadata will be stored in this database. Let's click next and finish. Okay, the idea here is that we have inferred the schema of S3 tables and they are listed here in this database. We have created target tables in Redshift where we will move the S3 data. The Redshift crawler will infer the schema from Redshift and create the new table in this database. Let's select the Redshift crawler and hit run. This will queue and run the crawler. The crawler will look into the Redshift database. It'll find the tables in the database, and in this example we have only one table, DIM product category. It will get the schema of the table and create a new table in the Glue catalog. The crawler does take a while, so I will let it finish. Okay, the crawler is stopping, which means it has finished. So we can click on tables and see a new table created here. It is the very first table. Glue appends the database and the schema in front of the table name. Rest of the table have the CSV classifier, while this one has Redshift. We can click on the table to see the metadata of the table. We can see the columns, the data type, and the location, classifier, and the database detail here. We can also view the additional properties by clicking on the View Properties button here. The makeup of the columns and the locations are stored in a JSON format. We also have the option of editing the schema definition, but we will leave it as is. The next step is to actually move data sitting in S3 to Redshift table. Our table is empty at the moment. All the crawler did is to look at the makeup of the table and created a similar table in the Glue catalog with the same column names and matching data type. In order to load data from S3 to Redshift, we will define a job. So let's go ahead and add a new job. Give it an appropriate name. We will use the same IAM role for this job. and we can change the language based on your preferences, but let's leave it to default for now. And we can leave the rest of the options as default. There are advanced options here. For example, bookmarking enables us to do delta or incremental load. Maybe we'll explore this down the road, but let's go ahead and click on Next. Here we select the source table. Since we are loading the data from the DIM product category table, we will select the source table from S3. So here we are going to select the DIM product category from S3 and click on Next. We'll leave these options as default, and here we will select the target table on this page. Our target table is Redshift table, so it is the first option. Let's select it and click Next. This is the column mapping between source and target. The data type of the first two columns are slightly different. In the source, they're stored as big int, while in the target, they're stored as long. Rest of the columns have the matching data types. All the columns are mapped between source and the target. Let's go ahead and save this job, and this will bring up the actual script that is performing all the actions we have defined in the UI. We can tweak the script if we need to add any additional transformation steps here, but let's go ahead and save and run this job. This will queue the job. We can click on the jobs on the left to view the status of our job. We will select it and it will display the current status. We can also view the logs for this job. Also, if there are any errors, we can view them as well. The first time job is queued, it does take a while to run. Although our table has only 4 rows, the AWS Glue is provisioning the required resources to execute this job. So we'll give it time to complete. Okay, our job ran successfully. We have a success status here. Let's go to our Redshift database and query the table. This time around, the query returns data. We have successfully loaded the S3 data into Redshift. We can also query this table using our local SQL client. I am going to add another client to query this data. We can query the Redshift data using Jupyter Notebook. So if you're comfortable using pandas and wants to manipulate or analyze this data using pandas, this is the way to do it. So I have a Jupyter Notebook open, and these are the required libraries to connect to Redshift. The main libraries are PsychoPG2 and SQL Alchemy, and we'll use pandas to query Redshift. I have added my access and secret key to a JSON config file along with Redshift credentials. We open and load the file. We access each variable using a key and save them to a local variable. Our database name is dev. I'll go ahead and update this variable. This is the SQL query we will execute against Redshift. We'll connect to the database using SQL Alchemy as usual, and all I have done is added PsychoPG2, username, password, host, port, and I need to update the database name to dev. Okay, we are ready. Let's execute the query using pandas. And we have successfully connected to Redshift, read data into a pandas data frame. And once we have data into a data frame, we can apply all the available functionality in pandas. I think I'll end the session here. So we have successfully connected to Redshift from AWS Glue. We have read S3 data and loaded the data into a Redshift table. We have queried the Redshift table with Query Editor, DBeaver, and Jupyter Notebook. This is all for now. Like, share, and subscribe. Take care, and I'll see you in the next video.